Hello out there, Algebra 2 scholars. This is Lesson 4 in Unit 10. This unit is all about logarithms and exponentials, which are inverses of each other. We started this unit with a couple lessons on simplifying exponents, evaluating exponents, and then we defined a logarithm. And in the last lesson, we practiced evaluating them. Just like exponents, logarithms also have properties that allow us to rearrange them and manipulate them. So we need to learn those important properties. And it turns out that for each property in exponents, there's an analogous property for logarithms. So they have a little bit of intuition that goes with them. Notice how they're just a little different, though, because they're inverses. Exponent properties and their corresponding logarithm properties is what I'm calling this table. So we're going to keep things simple by assuming b, x, and y are all positive numbers. We know that if we have the same base and we multiply them, we add the powers. So it turns out with logarithms, if we have the same base and we're adding them, we multiply them. So you can see that it's a little bit backwards. It used to be we would go from times to add. Now we're going from I think I was going add the times. But the log base b of xy, whenever you have multiplication inside a logarithm, you can split it up and make it addition. Likewise, when you have the bases are divided, you get to subtract the exponent here. If we have division inside a logarithm, we can split it up and subtract the logarithms. Power to a power we multiply. Well, with a logarithm, if you have a exponent inside a logarithm expression, you can actually bring it down in front and multiply it times the logarithm. That's a very useful property. And lastly, remember that b to the 0 is 1, so it makes sense that log base b of 1 must equal 0. I do prove these properties in the class notes. You can take a look at those and look at the end right after the exit ticket if you're curious on how to prove those formally. But for now, we'll just believe them. Okay, in example 4.1, we're going to use the properties of logarithms to expand the following logarithm expressions. To expand a logarithm expression is to try and break it apart and write the word log as many times as you can. And it results in as simple an argument as you can get. So the log base 2 of 3x, because I have multiplication of 3 times x, I can split it apart and make it the log base 2 of 3 plus the log base 2 of x. Remember, if you have times on the inside, you have plus on the outside. On the next one, I have the log base 5 of 6 plus the log base 5 of x plus the log base 5 of y. So you can see how I can just keep continuing that process for more and more factors. Here we have some division and some multiplication. So I have 7 plus the log base 2 of x. So log base 2 of 7 plus log base 2 of x. Then I'm going to subtract everything else. Now I can either put in parentheses, I could put parentheses here like this and say, well, these two things are multiplied. Or the way I prefer to do it is to just simply say that anything in the bottom of a logarithm is subtracted. So I'm going to subtract the log base 2 of 3, and I'll subtract the log base 2 of y. All right, earlier we saw how exponents can be moved down to the front and made multiplication. We could also multiply in the back. It's just that we would need to be real careful how we write it. So typically people write it in the front so they don't think it's part of the logarithm. So the log base 3 of 5x is what we get. But we can expand that further and make that 3 times the log base 3 of 5 plus the log base 3 of x. And notice how the parentheses are necessary. Alternatively, I could have called this 5 cubed and x cubed and made it 3 log base 3 of 5 plus 3 log base 3 of x, which is just what you get when you distribute. All right, the log base 2 of the square root of x over y. Well, first I'm going to realize that that square root is really just an exponent. So this is x over y to the 1/2, which I'll then bring down, and then I'll do the subtracting. Log base 2 of x minus the log base 2 of y. And technically, I don't have to put parentheses around the x because a logarithm expression ends whenever you do a plus or a minus. So it's up to you whether or not you want to use them. All right, practice 4.1, we have A, B, C, D, and E. So please work those problems. Pause the video and give them a try. All right, let's see how you did. You should have called this the log base 7 of 6 plus the log base 7 of x plus the log base 7 of y plus the log base 7 of z. On the next one, we have the log base 4 of a plus the log base 4 of b, then minus the log base 4 of c. On letter C, we have the log base 2 of x cubed minus the log base 2 of y to the 5th. Now I can bring those exponents down in front, making it 3 times the log base 2 of x minus 5 times the log base 2 of y. On the next one, I'll bring the 3 down first, so I have 3 log base 3 of a times b, which becomes 3 times the log base 3 of a plus the log base 3 of b. All right, on the next one, this is a 1/3 power. That's what it's saying. So I'll make this 1/3 times the log base 3 of x plus the log base 3 of y squared, and I'll put the 2 right there. All right, in example 4.2, we're going to use the properties of the logarithms to condense. So we're going to go the other way. So in some problems, you have to, it makes the problem easier or possible only after you expand. Other times, you have to contract, to condense the logarithms. Some problems, you have to do a little bit of both. So we need to make sure we practice going both directions. So the goal when you condense is to write the word log as few times as possible. So this one here is the log of 3 times a divided by b, and anything that's subtracted goes on the bottom. There we go. Let's try the next one. 2 log x. Well, I'll move that 2 here, and I'll move that 4 there. Now I can call this the log of x squared times z to the 4th. Okay, let's take a look at the next one. The log base 2 of x, that 3 goes up on the y, but because it's subtracted, I get y cubed down here. Then the next one is plus log base 2 of z. Well, that's going to go up here in the logarithm because this log base 2 of y was subtracted, but the log base 2 of z is added, so it goes on top. Unless there was parentheses saying otherwise, we have to assume that it's different. Okay, on this one here, we can realize that the log of a minus the log of b is equal to the log of a over b. And the whole thing's divided by 2, so it's like a 1/2 there. And we can bring the 1/2 up on top. So we can write it like this. Or you can write it as the square root of a over b. All right, for practice 4.2, please use the properties of logarithms to condense the following logarithmic expressions. All right, let's see how you did. You should have called this the log base 5 of x over y to the 5th. On this one here, you should have called it the log of a, and then b goes on bottom. But because it's plus log c, again, the c goes on top. And then another minus, so this goes back on bottom, and that's actually a d squared. All right, let's try letter C. Okay, so we have the log of xy, and that 1/2 power goes there. So I'll say over z to the 1/2, or square root of z. But then we need to put the 3 up. So this becomes the log of xy over z to the 1/2 to the 3rd power. And we could, apply that power now. We could have also distributed the 3 from the beginning. So there's several different correct ways we could write this answer. All right, let's take a look at the next one. This is the log base 2 of x over y when I combine it. But because there's a 3 on the outside, it becomes like that. Then I have the log base 2 of z to the 1/2. So when we combine them, we get the log base 2 of x over y cubed z to the 1/2. All right, on the next one, I want us to review some exponents, and I've got some, just some different tricks up my sleeve at times to make you think. So please give this practice problem a try. We've done properties of logarithms, so it's important we practice the properties of exponents. So go through and do practice 4.3. Okay, 7 times 2 is 14. Then I have a to the negative third when I combine these two, and then I have b to the 0 times, well, nothing, so it's just a 1. So times 1 doesn't change anything. Then I've got c to the second. So this is 14c squared over a cubed. On this one, there's lots of different ways to do it, but I like to move all the factors that have a negative exponent first. And then I'll reduce when I think we're actually done already. Let's try this one. So when you have a negative exponent, you can't just flip the inside and put the y negative 4x to 4 on top, negative 2x on bottom, and you'd be done. Or you can simply apply the exponent to each factor and then go from there. But first I want to deal with the minus in front of the 2. Since this is an even power, I know it's negative, but it's still even, that negative is going to become a positive. So we don't need to worry about it anymore. Then this is going to become 2 to the negative 2, x to the negative 2 when I apply this exponent to there. Now I'll apply it to the bottom. Y to the negative fourth to the negative 2. I multiply the powers and you can actually get it positive 8. And then this is x to the negative 8. And let's move everything around. So this will be 1 over, I get 2 down here. X down here. This x up here. And y to the 8th remains the same. This will reduce, because I can take 2 away from that, to x to the 6th. So x to the 6th over 2y to the 8th. All right, let's try the next one. Remember, we add the exponents when we multiply. So this is 2. I need to add 3/5 and 2/5. That's just 1/5. 5/5 is 1. Then 1/2 and 2/3. So 3 over 3 and 2 over 2. So 3 over 6 plus 4 over 6 is 7 over 6. And that's it for that one. All right, on the next one, let's move our negative exponent first. So this is y squared y to the positive 1/2. It's hard to see, but that's a negative and that's a negative. Over x to the 2/3 x to the 1/2. All right, now we'll start combining. This becomes y to the 5/2 on top, and on bottom this will become x to the 7/6 again. All right, on the next one we have power to a power, so we'll apply each one of those. 2 to the 3rd is 8. 1/2 times 3 is 3/2, and 2/3 times 3 is just squared. All right, evaluate these logarithms if you can. The log base 2 of 16. Start with that. Pause the video, please, and give it a try. The log base 2 of 16 is 4, because 2 to the 4th is 16. This is the common log, so we just count the zeros. It's 6, log base 10. This here, if you move the decimal 1, 2, 3 to the right, it would be in scientific notation, so that's a negative 3. Log base 1/3 of 27. We know it needs to be a negative number so that I get the 1/3 to become 3. But 3 to what power is 27? Well, that answer is 3. The log base 6 of 1 over 36. Again, it needs to be negative to make the whole number 6 become a 1 over. And 6 to the 32nd is 2. Log base 4 of negative 164 is undefined. For your exit ticket here, I want you to explain why the log base b of 1 must equal 0 for any allowable base. Think about that, and I will see you in the next lesson.